Hello and welcome to your geometry recording. We are in week 10 and also the week of October 17th. I hope everybody enjoyed their 3-day weekend this past weekend and is ready to get back in and start another fresh week. So at this time, I do want to make sure that you've got your math notebook out and you're ready to take good notes. So if you do not have a math notebook in front of you, go ahead and click pause so that you can grab it and take good notes that will help you throughout this week completing all your lessons. All right, so the warm-up question this week is more based towards a term that we use a lot in geometry. And we are going to see this term a lot this week, and that term is bisector. So I want you to write in your math notebook, what is a bisector in geometry? So define it. What does it mean in geometry? And if you can't remember what a bisector is in geometry, do a quick web search. You've got the World Wide Web available at your fingertips. So if you need a reminder, take a moment and type it in to do a quick web search. So go ahead and do that now. Go ahead and click pause and write your thoughts down in your math notebook, and then when you're done, go ahead and click play. So what is a bisector? What did you guys come up with? So in geometry, it is something that divides I should say a line. It's a line or line or segment that divides something into two equal parts. So let me finish writing that out. So again, it's a line or segment that divides something into two equal parts. So in geometry, that's something, it might be a segment. We might have a line or segment divide another segment into two equal parts. It might be an angle. So it is something that divides something into two equal parts. Equal parts is really important. Two equal parts. That's what a bisector does. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Otherwise, we're moving on. Alrighty, so what are we doing this week? And here is a look into what you guys are going to be covering this week. We're going to be covering Unit 2, Session 9, which is all about bisectors of triangles. Oops, there's that word we looked up. And then we're going to go on to the next session, which is all about medians and altitudes of triangles. And then in Session 11, we're going to finish up this week with the triangle mid-segment theorem. So continuing on with our exploration of triangles in Unit 2, and just a heads up that next week we will be taking the Unit 2 test. I always like to warn you when that's coming up. Remember that will also mean then that next week will be the last week to redo low scoring assignments. So reminder that you can only be submitting redos from the current unit we're working on. So you will be able to work through next week with those redos, but just a heads up that that is coming, that deadline is coming as well. And let's jump right in to learn about some bisectors of triangles. All right, so some of the, let's see. We know a bisector divides something into two equal or congruent parts. We already talked about that. And just a reminder that we use ticks. So if I were to draw in a bisector here, let's say this is my bisector, I can then use those little ticks to let the reader know that these two segments are congruent because of the one tick. All right, so we're going to learn about 3 types of segments that are found in triangles. So those three special segments are medians, altitudes, and perpendicular bisectors. So let's start with medians. And we're going to learn about these three different segments, and we're going to find that they're similar. They all have some similarities, but then they all have some differences. So let's talk about some of those similarities and some of those differences and what those properties are. So let's start with medians. So a median is a segment in a triangle that joins a vertex. So it joins the vertex. It starts at the vertex and intersects through on the opposite side of the triangle at the midpoint. So remember, a midpoint divides a segment into two equal parts. So here on this side of the triangle, we start at a vertex, and then it's going to intersect through the midpoint of the opposite side of that vertex. So there's more than one median. There's going to be three medians in every triangle because there's three vertexes. So another median can start at this vertex and intersect through the median of the opposite side. So that's what a median is. The two important properties of medians is that you start at a vertex and that you intersect through the midpoint on the opposite side. Now an altitude looks similar, right? It looks similar to a median. It starts at a vertex just like a median did. But what's different about it? Does it intersect at the midpoint? No, because it doesn't divide that opposite side into two equal parts. So for an altitude, it's going to start at the vertex, and then it's going to intersect the opposite side of the triangle at a perpendicular angle. So it's going to have a perpendicular angle when it intersects that opposite side. So it started at a vertex, but then it's going to have a perpendicular angle that it intersects the opposite side with. So that's how they're similar, both these, the altitude and the median. They start at vertexes, but what makes them different is how they intersect the side opposite to that vertex. So make sure you write these definitions down in your math notebook. If you need more time, go ahead and click pause. Drawing pictures. Draw a picture of what both of these are. Don't just use words. Draw pictures in your notes. Okay, so the last type of segment that we can have in our triangles is a perpendicular bisector. And a perpendicular bisector, we know first of all that when we've got something that's perpendicular, it's going to intersect another line at a right angle. So let's make sure that we know that perpendicular means right angle, so that will help us understand this type of segment a little bit better. So a perpendicular bisector is not only does it have a right angle, but it's got that word bisector in there too. So a perpendicular bisector, it's going to intersect at a right angle, and it's also going to pass through the midpoint of a line. So we know a midpoint divides something into two equal parts. Well, that's what a bisector does as well. So a perpendicular bisector kind of tells us what it does in its name. It divides a line segment into two equal segments, as well as intersecting at a right angle. So here would be an example of a perpendicular bisector. So here, segment PQ is perpendicularly bisected by line AB. Not only does it divide it into two equal parts, but it does it with a right angle, at a right angle. These two segments would be congruent. There is a theorem that you guys are going to learn this week about perpendicular bisector theorem. And what that says is that any point on the perpendicular bisector, so here would be our perpendicular bisector, segment BC is our perpendicular bisector because it intersects segment AB at a right angle, and you can see that it intersects at the midpoint. So this is our perpendicular bisector right here. So any point that lies on the perpendicular bisector is going to be equidistant from the endpoints, meaning that from A to H is going to be equal to H to B, HB. So segment AH is going to be equal to segment HB. Same with if we were to go up a point a little bit higher, AF is going to be equal to the distance from FB. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So let's go ahead and solve a problem using what we've learned about the perpendicular bisect theorem. So here we've got a triangle, and I've got a segment in my triangle. So what kind of segment is this right here in our triangle? Is that an altitude? Is it a median? Or is it a perpendicular bisector? So that's the first question I'm going to ask you. So what type of segment is this segment in this triangle? So let's look at the properties. So we're starting at the vertex, and we intersect the opposite side at the midpoint, but we also do it with a right angle. So because we have the right angle in here, it's going to make it the perpendicular bisector. So it is a perpendicular bisector. And what did we just learn about the perpendicular bisector theorem? Is that any point on our perpendicular bisector is going to be equidistant from the endpoints. So looking at that, oops, here we've got, I wanted a highlighter. Here's a point on our perpendicular bisector. This point is going to be equidistant to point M as it is to point O. So the perpendicular bisector theorem tells us that the distance from M to N is going to be the same as the distance from M to O. So we can use a what we're given now, these equations that represent the length of each of those segments, and set those segments equal to each other. So we would have 3x minus 2 has to be equal to 6n minus 14. Then we're just going to use our algebra and solve for x. So I'm going to start by adding 2 to both sides. I get 3x is left on the left, 6x minus 12. I'm going to start up over here. I'm running out of room down there. Get all my x terms on the other side of the equation. So now I've got 3x minus 6x, which is negative 3x, equals negative 12, divided side by negative 3. And I get x equals positive 4. So I guess I should have said solve for x. Those were our directions. That was missing. It's not showing up. All right, so we did that. We solved for x. Now, make sure you're reading directions. In this case, it only said solve for x, so we're done. If it said, like, find the length of NO, we would just plug in the value of x into this equation and solve for O, the length of NO. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. All right. So again, let's review. Because altitudes and perpendiculars are very similar, and I just wanted to review what an altitude is and what makes it different from a perpendicular bisector. So again, an altitude starts at the vertex and has to intersect at a right angle on the opposite side, where a perpendicular bisector also, well, it doesn't have to pass through a vertex. So it's going to intersect at the midpoint and with a right angle. So it does not have to go through a vertex. So just going to review again all the terms we learned. Altitude started at a vertex, intersects the opposite side at a right angle, where perpendicular bisectors, it's not necessary to start at a vertex. What's necessary is that that segment in that triangle is intersecting at the midpoint and at a right angle. So let's make sure we're understanding everything. Again, altitudes and perpendicular bisectors look very similar. Are they the same? Are they the same? So again, here's an example of a perpendicular bisector over here on the right. How is it different from the altitude? So an altitude, remember, it intersects at a right angle, but it doesn't have to intersect at a midpoint, where the perpendicular bisector has to intersect at a right angle and divide the side into two equal parts. Where in altitude, we don't have to divide that opposite side into two equal parts. Okay, and then last but not least, we had medians, and a median, we start at a vertex and intersect the opposite side at the midpoint. So here we don't have right angles involved like we do with perpendicular bisectors. It doesn't have to intersect at a right angle. It might, but it doesn't need to. I shouldn't say that. I should get rid of that whole last statement. A median is just going from a vertex to the opposite side where it intersects it into two equal parts. Okay. So let's compare all these. So there's three main characteristics that we were talking about when we talked about perpendicular bisectors, medians, and altitudes. So we learned about three different types of segments and triangles. Using a graphic organizer is super helpful because there's three things, three properties, three characteristics that we talked about when we talked about each of these threes. The first is whether or not it had to have a right angle when it intersected the opposite side, or intersected the side of the triangle. Whether it had a midpoint when it intersected the side of the triangle, and if it had to start at the vertex. So which out of our three have to start at a vertex? The median and the altitude. They're going to start at the vertex. Which ones intersect the opposite side at a midpoint? So which of these three, the perpendicular bisector, median, or altitude, have to intersect the side of a triangle at a midpoint? Perpendicular bisector does. It's got that term bisector in there. And median, think middle for midpoint. It's got one. And that's it. Altitudes will not intersect a side of a triangle at a midpoint. And then which are going to intersect the side of a triangle and create a right angle? Well, we know perpendicular means right angle, so that one definitely does. And then altitudes do as well. So each of these terms is going to have two out of the three of the properties. And this chart is a great way of organizing that so that we can see which characteristics each type of segment has. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so let's do a quick practice problem here. There are some red segments on three different triangles, and I want you to determine if that red segment is an example of a perpendicular bisector. So what are the two characteristics that a perpendicular bisector has to have? Perpendicular means it's got to have a right angle, and bisector means it's got to divide the side of the triangle that it intersects into two equal parts. So looking at this first red segment, is that a perpendicular bisector? It's got the right angle, but does it bisect one side into two equal parts? No. So this is not a perpendicular bisector. Let's look at this triangle down here. So here we've got the line that's coming through and intersecting. Is it doing it at a right angle? We've got the right angle. Does it cut it in the side into 2 equal parts? It does. That's what that tick does. Both those ticks tell us. So yes, that is an example of a perpendicular bisector. What about this one? We've got our right angle, but does it divide the side into 2 equal parts? There's not ticks there telling us that it does, so nope. This is not a perpendicular bisector. All right, moving on. Let's try and determine whether each of these triangles are altitudes. So we're gonna only do 1 and 2 just for time's sake. So go ahead and click pause and see if you can determine if both these triangles that I labeled 1 and number 2, if these are examples of altitudes. Altitudes. Are they examples of altitudes? So try this on your own, and when you're ready to check your work with mine, go ahead and click play. So what do we know about altitudes? They have to intersect at a right angle and start at a vertex. So does number 1, it starts at the vertex, but does it intersect the opposite side at a right angle? No, so this is not a altitude. Number 2, does it start at a vertex? Yes. Does it intersect the opposite side at a right angle? And it does. So this is a good example that you can have an altitude that occurs outside of a triangle. We can have one that occurs outside of the triangle. And you'll have that when you've got obtuse triangles. That will actually happen. And in case you did this top one, it is also a altitude. It starts at the vertex and it has a right angle. So yes, this one is as well, in case you did that one. All right, moving on. Going on to the next slide. Let's see if you guys, first of all, I've got a triangle up here with a lot of different points and segments. If you want, go ahead and click pause now and try these 3 on your own. This is a great practice opportunity for you. And we'll go through and fill in the blanks together. So if you want to try this first on your own, go ahead and click pause now, because I'm going to go through the answers. All right, so here, if K is the midpoint, so that would mean we could put in the midpoint of ST, could put in some ticks. So if K is the midpoint, then RK would be this segment, is called a what? Is it an altitude, median, or perpendicular bisector? What do you think? It is the median. If you said median, you are correct. All right, next, going on to the next one. Just gonna erase all those parts. If RK right here is perpendicular to ST, so let's put in a little bar or a little square to show that it's perpendicular, it's got a right angle, then RK is called a what? So we don't know if SK is congruent to QT. There's no ticks in there, and we weren't told that K is the midpoint. So we cannot assume that those are equal segments. We cannot assume that SK is congruent to ST. So the only thing we do know is that we start at a vertex here, and that we intersect the opposite side at a right angle. So that would be considered an altitude. And then the last one, let's get rid of what I drew in there. It says if K is the midpoint, so now we are told that K is the midpoint, so now we know that these two smaller segments are congruent, and we're told that RK is perpendicular to side ST, so we can draw in, and we know that is a right angle. So now we do know that this is a perpendicular bisector. So those are all 3 of the terms that we learned about this week. Going on to the last slide, which is time for the key phrase assignment. Let me throw that up. So you guys learned about different segments in triangles this week. Let's focus on 2 of them right now. Medians and altitudes. So how are medians and altitudes the same? And then also tell me, how are they different? If you need directions, reminders of how to complete the key phrase assignment, those are below. If you have any questions, remember guys, you do need to be asking those. I don't know if you have questions in an online class unless you guys are reaching out and asking me. So please reach out and let me know if you need help with anything. Otherwise, have a great rest of your week.